And welcome back. We are going to go ahead and dive right into our first topic here, which is that of derived classes. Now, there's a key concept that we need to learn first, which is that of inheritance. And you might be wondering, what does inheritance have to do with this? Well, it's a technique that's used in object-oriented programming languages, and it's actually a very common technique that's used. It's simply just a way for us to say, hey, if we have some kind of general class that we have, and we can define and compile it into a working class, well then we can make specialized versions of that same class that can be further defined with, whether it's more specialized instance variables or methods. So it's kind of, you almost think of it as like, using a template to work with things, but it's not a template. It's simply you're going to be passing along common features and attributes. So these specialized classes, we say they inherit the methods and instance variables of that general class. So if you had let's say a name method, then that name method could get passed on to the descendant here that we're going to look at. And we'll look at this with a little bit more examples to make this more concrete. But the thing we need to first think about is this concept of like parents and children. So with parents and children, how this actually processes inheritance, when it works, it's a process by which we take a new class, which we're going to call a derived class, is going to be created from a base class. The base class is that first general class that we just talked about. It's kind of a starting class, and then every class that comes out of that base class is, of course, a derived class. Now, the base class is often called a parent class, and a derived class is therefore called a child because the parent has the child, so the child belongs to the parent. Now, we can, of course, technically take this further, and you don't have to think about this one too much, but you can, of course, you can have, more classes that work up, so we could have a parent of a parent, etc., all the way up as many times as one. Eventually, you call those ancestor classes because they're going to work back to some base level, and we can also, of course, work the other way to get descendant classes. But you don't have to worry about that too much because, again, most of the time we're going to work simply just with the terminologies derived and base class because those are going to be some of the more common ones that you see. So let's look at inheritance and jump right in with some examples here. So a derived class, the first thing we have to understand is it automatically has all the instance variables and all the methods that the base class has, and can have additional methods and or additional instance variables. So let's just say we're going to make a record keeping program that has records for, let's say, salaried employees and hourly employees. Well, if we start thinking about this, there's kind of a natural hierarchy of how we can group these as classes. For example, these are all classes of people who share the property of being employees. So whether you're part-time, full-time, salaried, clerical, whatever, you're all an employee. Now, employees who are paid an hourly wage could be considered one subset of employees. Salaried employees who are paid a fixed wage each month are another set of employees. And this is really going to work into our concept here of derived classes because although the program may not need any type corresponding to, let's say, all set employees, we could just make a, salaried employee class and then just have a hourly employee class and not have them be related. However, thinking in terms of a more general concept for employees because it's a common thread can be very useful. For example, all employees probably have a name and they have a hire date. So when they started working for that company, and the methods for setting and changing the names or hire dates are going to be the same regardless of whether they're a salaried employee or an hourly employee. And therefore, the classes for hourly and salaried employees may be further divided as we're going to look here on our next slide. All right, and so just here's a quick diagram. Now, this doesn't necessarily have to be, the exact same way we end up doing our record keeping. This is just an example. We could split this off into different ways. But you can see here we have our employee class at the top, and then underneath we have an hourly employee and a salaried employee. So these would both be derived classes of employee. And if I look under hourly employee, you can see, for example, I have a full-time hourly employee and a part-time hourly employee. And again, these would be derived classes of hourly employee, which would mean that these would be descendant classes of employee. On the other side, you can see we get technical staff, executives, etc. So again, more derived classes that we can spin out here simply just from looking at the employee. Now, let's actually go ahead and get ready to define what these derived classes look like. What do we actually need to put into these classes to make them work? Well, let's just say we are going to define a class called employee that's include all employees, whether we say salaried or hourly, and then we're going to use this class to define classes for hourly and salaried employees. We could then, in turn, use those classes to define further classes, as we saw in our hierarchy. So for things like part-time hourly employee or full-time hourly employee, and so on and so forth. Now, what's interesting about the employee class is how we use it to create those further classes. How do we use it to create those hourly employees? How do we use it to create those salaried employees? Well, remember, our primary reason for defining the employee class is that we can then have derived classes that are specialized for those different type of employees. And that employee class is our base class. And because it's a base class, it's going to have its own set of definitions. And when we start looking at the derived classes like hourly employee, you'll see that it has the definition for, obviously, hourly employees. An hourly employee is an employee. So because it's an hourly employee, we would say that's derived of that base class employee. A derived class is defined pretty much just by adding the instance variables and methods to an existing class. We're pretty much taking employee and just adding to it. The existing class, again, is just simply going to be a derived class that's built upon the base class. And if we look at this in an example, employee is the base class and hourly employee is the derived class. And we'll look at this in an example with the actual code just to see how this actually works. But the way that we indicate that one class is derived from another is by using the phrase extends employee on the first line of the class definition. So you will look and see public class hourly employee extends. So super quick, I popped over to Eclipse here, and here's my employee class, and you can see we have a whole bunch of different methods in here. So we have things like, we have our constructors, we have our get names, get hire dates, so all our accessors, our mutator methods, we have a toString and equals method. And then if we look at, for example, hourly employee, you will see right here it says public class hourly employee extends employee. All right, and of course you'll see we have some constructors and of course mutators and accessors and stuff like that. But there's going to be some things that we're going to talk about as we move into this unit about certain things that we haven't yet seen before. Things such as this super invocation right here. What does that mean? We will look at that as we dive deeper into derived classes, but for now, this of course is just a good quick way for us to take a look at this. If I look at a salaried employee, you'll see it functions very similar. So you can see we have a public class salaried employee extends. All right, so subclass and superclasses are terminology that you might hear. And all it simply is just another way for us to say, hey, this is a derived class, that's just a subclass, and a base class is a superclass. All right, so if you ever hear those terms, first thing I want you to know is like it's the same thing as what we're talking about. It's just another terminology. We're going to continue to use derived and base class though. So when you define that derived class, so like hourly employee, one thing you'll note is that you only give the added instance variables or added methods. All right. If we looked at that code and we kind of go line by line, you'll see that the class hourly employee has technically all the instance variables and all the methods of the class employee, but we don't have to actually mention them in that definition. All right. So for example, we have like get name. All right, we don't technically need to put get name because it technically exists within employee. Now, every object of a class hourly employee has the instance variables called name and hire date because name and hire date exist within employee. All right, and because they exist with employee, we don't have to specify them in that definition. And therefore, that class and any other derived classes are said to therefore inherit the instance variables and methods of the base class, in this case employee, that they're extending. All right, wrapping up with inheritance here. Just as it extends the instance variables of the class employee, the class hourly employee is going to inherit any method from the class employee. So the class hourly employee would inherit the methods get name, get hire date, set name, hire date, etc., etc. So any of those methods that exist, it can inherit. So let's just say we create a new object of the class hourly employee Joe equals new hourly employee. Well, what happens is then the name of the object Joe can be changed using the method set name, which the class hourly employee inherited from the class employee. If we look at hourly employee, there is no set name method. And the inherited method set name, therefore, is then used just like any other method. Joe.setName Josephine. We'll see this in our example. You will see that there is no real change from how we would use this if we just had a singular class. So it's kind of a nice way for us to add functionality to our program without having to learn a whole bunch of new techniques. Now, if we look at inheritance in other classes, all right, because we looked primarily at hourly employee, and I did take a look at salaried. One of the things you'll notice is that they are, again, derived from that employee class. And they all function the same way. So the class salary employee is still going to inherit all the instance variables and methods of the class employee. And the great thing about inheritance, it allows us to reuse code, such as that which exists in employee, without literally having to copy and paste code into the definitions of the derived class. You technically can do it, but it's just going to make your program inefficient, and I would... All right, and just to wrap things up, I just want to show the demo here real quick. You'll see we have an hourly employee object here, and of course we have our constructor that we're passing in. And in here, of course, you will see we are simply just using the getName method here. Now, getName, remember I said, does not actually exist here within hourly employee. You'll see we have getRate, getHours, getPay. getName actually only exists here within employee. So that is a cool thing about derived class. So this class, our base class, has a method called getName. And even though Joe is a hourly employee, you'll see, of course, that they are getting the getName method from here, not from hourly employee. And of course, we have all the other things, so we can use setName and stuff like that too, which is also, again, setName does not exist here. We have setHours, setRate, and that's it. So it is a really cool, powerful tool having inheritance on our side to make our programs have that much